Hello, hackers! Sorry we started a little late. Technical difficulties. Let me... Actually, I just realized I didn't set up my... an iPad or something so I can view the Twitch. One sec. I'll be right back. All right. We're back. Let's get this show on the road. All right. Which microphone am I using? Am I using the good mic? No, I think I'm using the bad mic. Oops. 1 second. So you might be able to tell it has been a little bit without streaming, and I'm setting up still a new device here. Hold on, let's do this. Audio capture method. Okay. Nope, that doesn't work. Taking some advice and trying to stream on macOS, and this is a terrible experience so far. All right, let me just bring up the chat just so we have something going on here. All right, that's me. Perfect. Okay. Yep, it's 365 office hours. Okay. Let's oh my god. Now I'm debugging the iPad. This is like that XKCD comic. Okay. What were we doing? We wanted to change audio settings. Sound settings. Input. Okay. How do we get this? It doesn't even see the other microphone. We might just have to have a relatively crappy microphone. Alright, fine. Someone on Twitch says they can hear me okay anyway, so we're doing this. Alright, so... Oops. Don't exit OBS. All right, let's announce on Twitch that we're on Discord that we are live. Hold on. Okay, let's do this. So, we'll go hit the screen share and just dive in and answer questions along the way. Okay, let me actually test something. If I do this, okay, that microphone goes away and stops flashing my face. All right, boom. Okay, we'll have this a little more well done in the future, but that's how it is right now. Okay, can people see this? Let's see. All right, awesome. Seems to be working. Okay, let's roll. Any questions? This is an office hours stream, so I'm here to answer your questions. Otherwise, I have a couple of kind of things I've noticed that people have been seems to be running into that we'll kind of dig into. Some approaches to maybe debugging some of this stuff, but any specific questions to get us started, feel free to ask on Twitch. And then I'll also switch over to Discord a little bit here. Okay, awesome. Discord's just chatting about how the Twitch stream is live. How do you run the SQL query? Ah, okay. So, Small Quark on Twitch asked, how do you run the SQL query? They don't need the query, just how to do it via Python. So are you saying like for debugging, you want to write a SQL query and test out how it's how it affects the database? I'm gonna assume yes, and then we'll dive in. And so let's grab one of the SQL injection challenges. So we got Squealy, I don't know, 3, let's say. Oh, this one's 2. Let's do it. All right. So we're gonna hit practice mode. Log in to some, well, that one's not correct. There we go. All right. Grab Squealy 2 or Squealy 3. Let's do Squealy 2. All right. This one, wow, that starts so fast. This multi-node support is insane. Okay. All right, let's load up the desktop. Okay. Boom. We'll hit up 2 terminals just to see what's going on here. So, SQL Injection 2 has a slightly more complicated challenge file than 1, and it basically has a whole application, and this is really neat because it's actually a little application that you could fix the vulnerabilities and use, I don't know, to pass messages with your friends or something, or to authenticate them, I guess. In the beginning of the application, right, we create these 2 tables. Or sorry, we create the table for users. We insert a user into the table, and when we create the table, create it, as with an admin user with a random password. Awesome. And the question, as I understand it, is how do we actually interact with this? Like, there is something that we're supposed to inject in here. There's a SQL injection, and of course we have this query debugging that gets printed here that kind of makes us think that, okay, well, probably this is where the injection happens. And of course, we can kind of see this probably is where the injection happens. How do we actually interact with this outside of the context of the application itself? Because this is a huge kind of pain in the butt to deal with the HTTP request and the SQL injection and so on. And maybe this is actually a good excuse me, one sec, let me wipe coffee off my face. All right, this is a good kind of practice in debugging in general, right? So we have this application, it's complex. We've identified where the bug might be, but we need to play around with the bug with the application in a smaller, more confined context so that we can kind of figure out what the hell's going on, right? Well, this is kind of a general pattern. We can copy it over to a different file. Okay, and we can trim it down, right? We don't want to deal with all the web stuff over here. We don't have to. We can take this whole thing, and we have this database. All right, perfect. So why don't we just start deleting stuff? Here's the query. Okay, awesome. Just delete everything else, or don't delete the actual query execution. We'll keep this. Okay. And basically we will just print user here instead of trying to do whatever. Here, instead of using Flask, we'll print this. Here, there's already in there. Okay, awesome. And we just delete the rest of it. Boom. So now we've taken our complex web application, we stripped out the web part, and we created something that we can interact with directly without having to deal with HTTP, curl, and all of this stuff. If we run this, it doesn't work because, of course, we don't have a username or a password. So let's take the username and password as command line arguments initially, and we can do whatever we want past that. So now we'll say username equals sys.argv1, password equals sys.argv2, take them on command line. So username is U and password is P. We hit enter, and here's the debug query output. We can see our query was created with the U and the P. Okay, pretty simple. And then the result of the query is none. So no user was found, right? So let's actually add some additional result. Okay, there we go. So awesome. Now we can debug this thing. If we wanted to go even farther, instead of taking username and password, we can just take an input for the whole query. Right? So now we just run it. Okay, and instead of fetch one, let's just put over here fetch all for SQLite. And of course, I know this API, but you can look up the SQLite documentation. You'll need to do stuff like this throughout the course. And we run this, and I messed up my Python. Run it. Cool. I've got 2 rows returned from here. I can do a really cool thing. If I use IPython, I can pass the -i flag, which will allow me to continue interacting with the Python interpreter state even after executing this thing. Okay, I do this. All right, now I'm in this shell. Wait, what? Oh, IPython is a little bit annoying. One sec. We'll just do -- this, everything before the -- is arguments to IPython itself. Everything after the -- I messed that up, sorry. That was me memeing, ignore that. I forgot my file name. My server. There we go. All right, so we got our result. We can check the results. Result 0, awesome. Result 0, sweet. Let's see, password. Okay, that's the random string username. Yeah, we can just play around with these things. I can just get all of the fields. Let's see if this works. I've never tried this before. Awesome, cool. So it's pretty interactive here. I can execute additional queries. if I want. I can see what happens when I insert an additional thing. Insert into users, select Jan as username, Jan pass as password. Awesome. Now that executed, now I can execute select star from users, fetch all. Now there'll be 3 things here, and you can user s, and you can just kind of see I'm playing around with the database without the pain in the ass of HTTP. I can tweak my attack here, so I would uncomment this guy. Whoa, what's going on? Keep hitting the wrong buttons. Uncomment this guy. Uncomment this. Okay. So now here's a username and password. Actually, I can do... Yeah, I can just start messing around with this. So here I have the ASDF. Here I have DSA with a quote. And I can see what that does to the query, right? Without having to deal with HTTP. See, oh look, here it is. And then we got an error from that query. Awesome. So in general, what did I do to debug and kind of interact with this thing in a reasonable way? I stripped out most of the application and I just started interacting with it directly. And maybe a good thing for us to do next year is to launch an intermediate challenge that is SQL injection on the command line, not on the web. Maybe that'll be much simpler. Cool. Okay. Questions on Twitch while I was going through that. All right, the first one, we'll come to that next. This stream will be saved for later. All of our streams are saved for later. Okay. Perfect. Okay. Let's answer kind of the big conceptual question here. You start on this challenge, right? You open up the challenge file. What are you supposed to do? How are you supposed to find what your actual goal with the level? Your actual goal with the level is always actually quite simple. You have to get the flag, right? So this sounds kind of dumb because, yeah, of course that's the goal. That's how you grade the challenge. But that is what informs you as to how to proceed forward. So you need to retrieve the flag. Cool. How do you retrieve the flag? Well, here you retrieve the flag by logging in as admin, right? So starting from this, my goal with every level is to get the flag. You look at the program and you take one step backwards and you say, how can I get this program to give me the flag? And there's functionality in here. You can just search for flag. There's functionality in here. It only shows up here to get the flag. And if you hit this thing in a web browser, it'll tell you, hey, go get the flag. So I'm going to hit this in a web browser. Okay, server's running. We're going to start up a web browser. Okay, and it says log in as admin to get the flag. Boom. It even tells us what to do. Okay. So then the question becomes, how do I log in as admin? Because you have a clear path to get the flag, right? How do you log in as admin? Well, you need to either steal the admin's password. Okay, that would be this random 8-byte string, or you need to trick the login code so that it logs you in as admin, right? Given that this login code is the unique part of the challenge, especially if you go through these challenges in sequence, you'll see this is where things start shifting. The login code is what to focus on. Even if it wasn't the name of the challenge, that it's a SQL injection, the description of the challenge very clearly point you to a SQL injection, right? So then you say, okay, either you rely on the name of the challenge, say, and the title of the topic of the module, and you say, well, how do I SQL inject here? And then you search through all of the queries, and queries are executed with db.execute, and you go through and you say, okay, well, how would I inject this? Right? And this query uses something called, I'm drawing a blank because I didn't have a lot of sleep. The fuck? Prepared statement key is coming to mind, but that's not it. All right, I'll follow up. Anyways, this query is put together on the SQL Server side itself. This is the query that's passed to my to SQLite, the SQL library here, and then this is passed as an argument, and these things never get combined into a string. Right? This is not injectable. This is a safe way to use SQL. Okay, so let's say not there. This has no parameters at all. I mean, they're all hard-coded, so that's not injectable. This is a third query. It looks pretty suspicious because it is a dynamically built query. These things are typically a very bad idea. And so over here, say this is what's injectable. Cool. So you start out with, you need to get the flag. You go on to get the flag, you need to log in as admin. And then you move on to log in as admin, I need to SQL inject. And then you identify the candidate set of SQL statements that are injectable. And then you're left with these 3 lines. So you've simplified the 70-line function into basically 3. And then you hyper-focus on that for a while. And only if that doesn't work, you're really not getting anywhere, as in you haven't even been able to trigger any suspicious behavior, then you start looking at other things. But in this case, you'll trigger the suspicious behavior pretty quickly. Okay. Lost sound. Do you guys not hear me anymore? Oh, I can hear myself on the iPad. So I think it is, yeah, okay, sounds good. All right, awesome. So that's how you would approach this. So then the question was, okay, what about path traversal, where the word flag doesn't show up in the code at all? So let's go back up, start up path traversal here. Okay. Pop up a shell. Okay. This is a much simpler program, and also is very interested in that there is. So again, we open this challenge. We say, hey, what's my goal? Goal is to get the flag. That is your goal every time in this class, right? In an actual cybersecurity situation, your goal might be a lot of different things. Your goal might be to demonstrate that a system is insecure by breaking into a user account. or by violating any sort of security policy. In this case, the security policy relevant to pwn.college is the flag does not get exposed to the student. So that's what you got to violate. All right. So here, you start out, you search for flag. Say, okay, there is no obvious way to read the flag here. Okay. Well, that's interesting. So now we have to start thinking. All right. How would we actually get the flag? Well, one way to read the flag is to open the /flag file and read it. Or in other words, you start looking at this application and say, if the application doesn't explicitly and purposefully leak the flag to me, like the SQL injection case did, how would I trick it into doing so, right? There's only one place in this application that can read a file that you have any control over, right? That's the other thing. What parts of the application that I can influence can read the flag. This part happens before you connect. All of this, you have no influence. You're not going to somehow hijack os.urandom, which gets 8 random bytes, puts it into the secret key of the application. You just that's unavailable to you. Okay. This happens before. All right. This happens, gets run every time you do a get or a post request. Cool. So now you can start thinking about, okay, well, what here? This is all stuff, say, I might be able to influence. What here could get me the flag? Right? Can this read the flag? No, it's just a string concatenation. Right? It doesn't actually read files in a sane programming language like Python. Can this get me the flag? No, it's just a debug print. And then you say, can this get me the flag? Well, wait. This opens a file, reads it, and returns it to the user. This seems like a really good candidate. So we add that to our candidate list. And we say, can this get me the flag? Doesn't look like it. This just returns in an error statement the path. Can this get me the flag? This can get me the current working directory of the server. That's kind of cool, except for I already know it. It's going to be the /challenge directory. And this gets me an error. So this, let's note it down as a secondary thing. If we can somehow get the flag into the error message and get it returned to us in an error, then we can leave the flag, right? And this happens, just not in this challenge. So we'll put it as a secondary on the back burner and focus on our awesome candidate. The ability to open a path and read it. Okay, now, one sec, my daughter's passing notes under the door. Спасибо, Мариночка. Молодец. We got a note here. She's learning to write a little bit. It's pretty good. Awesome. Okay, so keep that note in mind. Maybe it's a hint. No, I'm just kidding. All right. Someone's asking for this to be full screen. Let's see if we can. There we go. We can zoom in a little bit. Zoom in a little bit. All right. We'll get the streaming set up a little better. Like I mentioned at the beginning of the stream, I'm trying to use an iMac here so that we avoid stuff like Wayland killing OBS, but it has its own problems. Okay. So, what were we talking about? We had identified this as an interesting, suspicious thing that could get us the flag, because we have control over this. This comes. Спасибо, Marina. One second. Молодец. It's also learning to draw stick figures. It's pretty good. Awesome. Okay. So this path that is passed to the open function in Python is controlled by the user. It is right here, and it is right here, and it is right here as an argument to Flask. Cool. So the user controls this, but there's limited control in that right now, in path traversal 1, this was just the raw path. In path traversal 2, we strip out the dot and the / character. So you partially control this path. So then the question becomes a conditional one. It's like, under what conditions could I control this path to the extent that I need to control it to leak out the flag? And to answer that question, you really need to understand the strip function. So now we go onto an Odyssey to look up documentation, right? We pop up Google and say Python strip. Okay, the strip method. I like the official docs. Here we go. All right. So here's like the actual, data type documentation in Python. Search for strip. That's lstrip. I don't know what that is. We're not dealing with that right now. Strip. All right, what does it do? Return a copy of the string with the leading and trailing characters removed. The chars argument, that's what we had passed in, is a string specifying the set of characters to be removed. Okay. The chars argument is not a prefix or suffix. All combinations of its values are stripped. Well, that's interesting. So that set tells us that whatever we enter here, we'll strip out any combination from the beginning and end of dots or /. And we can play around with this. Right? And we will do so right now. So we pop up IPython. So we say, okay, what if path is ASDF? And we can do path.strip / dot. Okay, that gets us ASDF. Interesting. Say ASDF, dot / ASDF. When we strip it, oh, that's what happens. That's interesting. If we make path ASDF like that, that's what happens. Okay. We kind of started just playing around random stuff. Oh, that's interesting. So you can see it's stripping from the beginning and the end, but not the middle. I'll leave you at that for path traversal 2. Okay. There's another kind of fundamental question. How do you learn about all of this? Right? I was talking about flask.abort. I was like, this just sends an error message. How the fuck are you supposed to know this? Right? Like, you've never had a Flask class. There isn't, Flask in CSE365 or whatever earlier curriculum. Computer science, modern computer science, is of a breadth that is simply unattainable in a quick curriculum. Right? You had 2 years of computer science before hitting this class. And there are certain things that I feel you should know by now that, we're trying to introduce rapidly here, but Flask isn't one of them. I don't expect you to have ever seen Flask before. But I do expect you with this class to learn how to rapidly learn, right? So Flask is a good example. You see this for the first time, and you can't, if this is confusing from a what's going on perspective, well, Flask tutorial. Boom. Flask has a tutorial. All right. And we can dig in and see here, little test application. We can read exactly what's going on for every Flask API used in this little application. I can do Flask abort. It's Google. There's a Stack Overflow. What does Flask abort do? There's an answer. Flask abort method accepts an error code, accepts a response object. Okay, that error answer is not very useful. So let's go. Okay, how to use the Flask abort. All right. That's just code examples. Okay. Tips and tricks. Look at that. The abort function of Flask raises an HTTP exception for the given status code. It's helpful for writing a view function when error is, for exiting a function when the error is detected. Okay, that's cool. So it exits the function, returns an HTTP exception. Okay, here's another Flask documentation thing. Handling application errors. Let's search this for abort. Flask comes with a handy abort function that aborts a request with an HTTP error from, I have no idea what this is. I'm going to put this in a box in my head for later and abstract it so to replace it with something, right? So Flask comes with a handy abort function that aborts a request with an HTTP error from something as desired. Of course, I know what this is, but you don't have to know what this is. It aborts a request with an HTTP error from something, right? It'll also provide a plain blank and white error page for you with a basic description, but nothing fancy. Okay, that's enough for us to read this code. If there's a permission error when opening this file, we abort with an HTTP 403 error code. Okay, what the hell is that? Well, let's search HTTP error codes. And we come here to this very nice document that has a bunch of these HTTP error codes and 403 forbidden. Just an error code that gets sent to your browser. Okay? And the message that it sends along is the path that was forbidden. Cool. Let's trigger this. So if I just run challenge server, it's going to run as root, etc., etc. If I copy it out and run it now, that's weird. Okay, run it explicitly with Python, and well, I have to do some setup, so it needs a files directory, and in this files directory, I'll make 2 files. Okay, and I will make one of them. Okay, for permission denied. Okay, the chmod, you learned a lot of chmod, but we mostly taught you the symbolic way of doing things. What I just did is user group owner minus rwx2. That removes all permissions. And now we have a 2 file that has no permissions. Okay, we recreate the scenario here. We curl challenge.localhost. When we run it ourselves, it opens up port 8080 here. Practice, okay. All right, no index here. So here's 404 not found. That's another one of these error codes. When there's no file found. Okay, that's cool. And here we see our error. No home hacker from, okay, very cool. So then if we say, let's get the 1 file, that works. That's our high file. We try the 2 file. Boom, 403 forbidden. Permission denied for this guy. Cool. All right, awesome. So now we've learned, just from looking at this, Flask, and then Flask.abort, and what's left? App.route, I guess, is new. A lot of this other stuff is new. But the key thing is you're going to be exposed to an enormous amount of different knowledge, different APIs, different frameworks in this class. Already, in these first several levels, or let's say this first module, you have been exposed to just Flask. This is your first exposure to Flask in these two levels. And you've already seen the shell, so this is nothing new. This, you start getting into SQL, right? That's a huge thing. That's a huge additional technology that maybe you've never seen before. You rapidly have to learn enough to understand the challenges. And that's the key. When we were reading this HTTP handling errors thing, there's this crazy word, Werkzeug, right? You can Google this and you can go down the rabbit hole of Python's HTTP server standard APIs, etc., 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 etc. But you don't have to. You can abstract it. Say this is something. If I hit a complete dead end, and with the knowledge available to me, I've stalled out here, then I'll dig in. If I have no other promising path to getting the flag, I'll go learn what that thing is. And then I'll see if that has a bug or has some security property that'll allow me to get the flag. But until then, I have learned what I need to learn. Oftentimes that is deeper than the average developer of the tool digs in, of an average developer using Flask. You might at some point, and this is just an example that doesn't actually hold, but at some point you might have to dig in and understand exactly how abort works. There's no challenges in pwn.college that need you to understand exactly how abort works, but you might face an analogous situation where you need to dig in and understand deeper and deeper, but a lot of doing this wide security analysis is understanding things just enough to be dangerous. Cool. All right, so that's for Flask, right? You could ask a similar question for SQL. So if we go and launch up one of the SQL injections. It's so fast, it's insane. All right. Launch up one of the SQL injections. And now we're looking at the server here. That's too big. All right. You might say, okay, well, wait a second. What is all of this temporary DB stuff? Here, we just use it. And so what I would encourage you to do, rather than trying to understand the script line by line, is to understand the script at a high level and then dig into the parts you don't understand. So what does db.execute mean? The db.execute, and then you get a bunch of different things for a bunch of different technologies. That's too broad, right? So then we just go in, okay, well, db.execute, db is this temporary DB. Temporary DB is a Python class that provides the execute method. What that actually does is do this weird, here's our SQL query. Okay, we connect to a database. We do something weird, Then we pass our SQL, aha, that's controlled by us. So what does that allow us to do? Well, let's look at cursor.execute, and cursor is a result of connection.cursor, and connection is a result of SQLite 3 connect. So we're gonna search for SQLite 3 connect cursor execute. And it brings us to the SQLite documentation, which we can read here with plenty of examples to understand how this stuff works. All right. So that reading documentation or digesting documentation module of the Linux Luminarium, man pages aren't the only source of truth, right? They're a great one, but in this module and very heavily in future modules as well, you'll have to Google, you have to read documentation, and so on. Cool. All right, what else do we got? Other questions? I mean, I think at a high level, a lot of people are asking, like, how are we supposed to know this stuff, right? Well, I don't expect you to know a Flask. I definitely don't expect you to know Flask. But I expect you to learn it enough to interact with the challenges, to understand those security issues. In a very real way, this class is about learning to learn fast. Learn what you need to approach the assignment, to explore the security issues fast and just enough to be able to dig in. There's a class of cybersecurity competitions, a class being a category in this case, not a course. A category of cybersecurity competitions called Capture the Flag, which is what pwn.college is modeled after. A typical Capture the Flag contest, if we look up the kind of global tracking website of these, a typical contest in Capture the Flag lasts for 48 hours. Here are the ones that are coming up, right? So we have 5 contests coming up in the next 2 weeks. If you look at this one, for example, this starts on 5 p.m. 5 p.m. UTC on Friday and goes to 5 p.m. UTC on Sunday. So that is 24 hours. A typical contest that's 24 hours long. Let's look at one that just finished. Right now, wow, there's 6 of them running. One that just finished is, I don't know, let's look at Cyberspace CTF. Cool. If we look at the challenges here, let's look at something that's running right now where we can look at some challenges. Does this have its challenges open? Seesaw is a big undergraduate one that runs every year that I have to log in. All right, a typical CTF will have anywhere from 15 to 30 challenges that a team of hackers will typically attempt over the course of a 48-hour weekend, right? Each of those challenges might require the hackers trying to hack them to learn a completely new technology. One of my kind of go-to examples is to solve a reverse engineering challenge. This was years and years ago. I learned Verilog in one weekend, deep enough to implement a timing attack against a Verilog circuit, and no deeper and no shallower, right? You have to know how to very rapidly learn this tech, to learn a new crypto algorithm, to learn et cetera, to deal with emergent security situations. A 48-hour Capture the Flag competition, that's not very, real world, right? But a 2-week-long security assessment engagement, that happens all the time. If you can learn something in 48 hours, you can learn it in 2 weeks at less of a breakneck speed and so on. And these assignments, they're 2-week assignments where we do expect you to learn a number of new technologies that we don't explicitly handhold you through. We don't have Flask lectures. You have to find the Flask documentation and learn that on your own. And a lot of the feedback of this style of courses is, well, you didn't teach me Flask. That's absolutely true. And someone on Twitch said, experience like this gives you confidence to be able to go off and learn on your own. And that's probably the most important skill you'll get out of this class, more than how to exploit patch reversals. Patch reversals are a real world problem if you actually look at, for example, what's a good CVE search? CVEs are the common vulnerability enumeration is basically a scoreboard for vulnerabilities. So we can search for patch traversal and find recent vulnerabilities that were reported with patch traversals. All right. So there's an application ABCD2, and in ABCD2 up to version 2.2.0-beta 1, there's a command path traversal. There have been, just this year, an enormous amount of path traversals. This thing that you're learning to get flags on pwn.college, I mean, these are real bugs in real applications that's a lot of path traversals. Actually, that's more than I expected to see. That's all from this year. That's CV 2024. All right, finally we're in 2023. All right, real bugs that someone's found in real applications and reported and got credit for and put on their CV. Let's see, vendor Smarty Pants, and the credit goes to Catfather. Pretty cool, huh? So you too can have your handle on a CVE if you learn path traversals well enough, or let's say SQL injection. There's a better way to search these things than by keyword, of course. They're like categorized and everything. Boom, SQL injections. In 2024 alone, we just keep scrolling. Keep scrolling and keep scrolling. This is how many SQL injections exist in the world's software just this year. That were found just this year. Holy shit. Wow. Oh, there we go. Finally, we're done. All right. Now we're in last year. Okay. So, comment on Twitch. Yeah. Building up this skill of, like Luggy Boy on Twitch says, quickly learning the fundamentals and finding the fundamentals. You'll notice when I first searched for db.execute, it was the wrong thing to search for, and I got weird results. Figuring out what to search for, how to learn it fast, and how to maintain the right abstraction so you don't go into these crazy rabbit holes. That's an important skill. And I think the only way to teach that skill is to come at you all with 27 crazy hacking challenges. All right. Awesome. Any other questions for today? Let me check Discord. The link in the chat didn't work. That's weird. All right, but people are here, so the stream is working. The link is adding the exclamation point. Oh my god, that sucks. Let me add that link to remove the exclamation point. Discord needs to be a little bit less eager with links. All right, link edited. Sweet. All right. Okay. Sweet. Other questions, comments, etc. Like I said, there's an office hour stream. I'm here to answer your questions. Could I please go over command injection 6? All right. I'm not going to solve command injection 6, but I will take a look at it. I mean, obviously, I wrote this thing, so I know how to solve it. All right. So command injection 6 has a pretty big hint. You'll be stumped for a while, but will laugh at its familiarity when you find the solution. Let's take a look. How did I mess this up? All right. What do we got here? This is bigger than our previous command injection challenge. Well, if you were looking at them, they're all pretty simple. So what is this? It's the dir lister service. We choose a directory to list the files up. And so, okay, we've been looking at this whole thing in a text editor, but it actually really helps to interact with these things and see what do they actually do. So let's do that. All right, here it is. No, that's a previous cached page because nothing's running. Okay. Here we go. Welcome to the dir lister servers. Choose a directory to list the files of. This is a /challenge, so you can do /. Oh, that's cool. And this might seem like a silly thing, but if you ever logged into an interface of your Wi-Fi router, it often has a ping, like a ping option, where you can put in an IP or a host and it'll ping it. A trace route option, a couple of other utilities like this. Typically, this is how they're implemented, and typically they're, well, not typically, but often they are command injectable in this exact way. All right, so very cool. You can do /. Now, of course, we could say, okay, hey, what if you do ... Oh, that's silly because we can already do /. What if we do /flag or the ls/flag? That doesn't get us the flag, unfortunately. And in previous command injection challenges, as you know, even the hint tells you, you can just put a semicolon, right? And what happens there? Well, you know, there you would normally terminate a command and start a new one, and then you can do whatever you want. But in this case, the challenge removes the characters that you have so far used for your command injecting purposes, right? So if you get the directory from this form and we replace it with, we replace all these special characters with all this stuff, and that's really annoying. So now what? Right? So, you know, this semicolon is an obvious one. Pipe you have used. This, another command injection methodology that you might have seen from, might remember from Linux Luminarium. But all of this gets wiped out. So we sit here and we say, well, fuck. How do we command inject? Well, very clearly, this is trying to do character filtering. And character filtering is very hard for many numbers of reasons. One is, in order for, well, that's interesting. That was I guess one of those FaceTime effects. Okay, one reason why it's character filtering is hard is the defender needs to understand the exact functionality of every character possible to send and what it does, and that's simply impossible. I've seen, let's see if we can find it. There was an awesome SQL injection technique where people were filtering out quotes and stuff to try to keep their queries safe that they were building. If you've ever, I'm trying to remember what's a good example here. If you've ever submitted, for example, if you send money using Zelle, and you try to put in your description, like, you know, why the money is for, try to put a quote or I don't remember if they allow periods, but they don't allow single quotes, etc., right? So if you send someone money on Zelle and you put as a description, Jan's birthday party with an apostrophe S, it'll tell you, hey, no special characters. That apostrophe is not allowed. Why do they say this? Because Zelle is a huge conglomerate interaction between a ton of different banks, and that data is going to end up in 100 different systems. And whoever wrote Zelle just knew, we're absolutely certain that one of those systems would be command injectable, or special character injectable in whatever context. Not command injectable, I meant to say. They knew that it was going to be SQL injectable, or command injectable, or possibly CSV injectable. There's all sorts of these injections that occur, and so they said, okay, you know what? We're just going to filter out any special characters that might be a problem, just to avoid someone having command execution inside a major bank, right? Did they filter at all? There are bugs that occur in Unicode characters, for example. These are all UTF-8 encoded strings. UTF-8 is actually really complex, and MySQL, for example, and this isn't MySQL, this is the shell, which isn't as complex, but certain SQL database servers, this is extra information you don't need for any of this assignment, and I wouldn't put too much stock into this, but certain databases will actually treat Unicode quotes as quotes, and so then you could use that to escape and to SQL inject. All right, cool. So in this case, we're assuming that the developer assumes that they looked at every character and they know every special character that has any meaning in Bash, and they wiped it out. Is this really likely to be the case? Probably not. Let's take a look. So we find a list of all characters. Cool, list of Unicode characters. All right. There's 154,998 Unicode characters. We just look at each one of those, just one by one. So let's scroll down. All right. And we just look at each one, and eventually we'll find maybe something that the developer didn't think. But of course, this is way too big. All right. So Unicode, all of Unicode. Unicode's a text encoding. Read about it on Wikipedia. Actually, read about UTF-8, which I mentioned, but it's not important right now. The important thing is, hey, this isn't, the web circa 2024. This is the command line. The command line hails to us from the 80s, and the dominant text encoding paradigm of the 80s is ASCII. And it has a man page. These are going to be all of the characters that matter in Bash. So ASCII has the character codes in different bases of every character. So capital A in ASCII is hexadecimal hex 41. That's a representation of 8 bytes of binary, and a decimal value of 65, an octal value of 101. So this is, if we're flipping bits in a file, of course, all of these things are stored in files here on the file system. If we when we open up a text editor and we type stuff, it saves, of course, bits on the file system. Maybe hex dump FDSA. So here I did AAA, here hex 41, hex 41, hex 41, hex 41. Very cool. All right. Anyways, that's not so important, actually. I went on a tangent. I apologize. We're just I'm starting to fade after an hour. Not enough sleep. Okay. Here are the special characters that could be relevant. And we can see if a lot of them are filtered out. There's some non-printables that are also interesting. Like, what if we send a null byte? What if we send a backspace character? Well, are those special? Bash doesn't treat those special. But there are other characters in this big long list that it does treat special. Obviously, the letter G is just the letter G. What about a backslash? What about, that's not the answer, but I'm just thinking out loud. What about going one by one and proving to yourself that they aren't important? If you can't disprove their importance, then maybe you should try them out. Cool. Thank you for the birthday wishes. It wasn't my birthday. That was just an example. But, you know, my birthday does happen once a year. All right. I'm going to cut it here. Had a good hour. We will... So, okay, very important. If we go... Oops. We go here. You go to your course. And you hit web security. Oh, and you are logged in as a student. It will tell you when this is due. That's very important. Do we have access to this if you're not a student? The checkpoint for web security is Sunday night, tomorrow night at 11:59:59. All right. Please get the checkpoint. You just need 8 of these challenges for the checkpoint. If you're stuck on command injection 6, leave it for later. These are roughly, until much later, quasi-independent different sets of I mean, they're all kind of build up on common concepts in that they're all implemented in Flask, for example. But, you know, you get batch traversal 1 and you're really not getting 2, put it on the back burner, move on to command injection and give it a try. You need 8 of these challenges for tomorrow. It's the checkpoint deadline. You get 30% of your credit tomorrow. You get it or you don't get it for 30% of the challenges rounded down. That's 8. So you get 8 challenges. You've secured 3% of your grade plus whatever 30% of the remaining 70% of your grade. Cool. Okay. Awesome stuff. I will let you all go. Thank you for dropping by. Let's put us back. Boom. Full screen. And sorry about the technical issues that led to starting late. I think the next time will be much smoother. All right. Goodbye, hackers.